Give me one product that doesn't have semiconductors, maybe a pencil. Otherwise, every product today has semiconductors, so you can't do without it.
The concept that India can be a hardware nation and not just a software or a services nation, is that a legitimate ambition for us to have?
You see, the earlier governments, and specifically, I won't name the person, but I went to a minister one night, and that was about 15, 20 years ago. And I said, we are doing a great job in software, but we're doing nothing in hardware. So he said, doesn't matter, let China do hardware, we'll do software. That was the attitude. Now that attitude has completely changed because I believe that hardware and software are two sides of the same coin. Make in India alone is not good enough. I think we should have design and make in India for every product that we can think of, including semiconductors and electronic products.
So it's the entire modern technology, modern civilization pretty much riding on semiconductors.
But something very interesting is happening as a result of the sanctions that the US has put. China has started to make machines. And they have become totally vertically integrated. They now have everything that you need to make a chip, from design to manufacturing, to using manufacturing machines, to packaging and then selling. And if we don't have technology sovereignty, which means end-to-end development of a product, we're going to be really, really constrained over the years.
Hey everyone, and welcome to the India Story podcast, where we keep taking a look both at the India story and how it can be accelerated and taken forward. So today we're going to be talking about semiconductors. Can India become a semiconductor giant? And who better to talk to us about it than Ajay Chaudhary, the man often described as the father of Indian hardware, advisor to the semiconductor mission, your chairman of the quantum mission. So you really understand the sector better than virtually anybody else. The question I began by sort of asking, can India become a leader in semiconductors, in quantum, and in hardware?
I think many moons ago, I wrote about it and I said to the government around 2019 that we should have at least two fabs. But none of the earlier governments did anything. And as a result, we have lost a lot of time. But the good news is that we are doing a great catch-up at this moment. And good decisions are being taken by the government. And recently, if you look at in the COVID period, we all realized that a shortage of semiconductors can completely destroy the industry. So the semiconductor has become the center of it all. Give me one product that doesn't have semiconductors, maybe a pencil. Otherwise, every product today has semiconductors, so you can't do without it. And as a large country, all the more.
Well, I'm going to, when we come to what India should do in the specific policy, prescriptions for that, I'm going to come to that in just a couple of minutes. Also, perhaps get you to go over the history of semiconductors. But the question of hardware and software, first of all, you're one of the founding members, of course, of HCL. So the concept that India can be a hardware nation and not just a software or a services nation, is that a legitimate ambition for us to have?
You see, the earlier governments, and specifically, I won't name the person, but I went to a minister one night, and that was about 15, 20 years ago. And I said, we are doing a great job in software, but we're doing nothing in hardware. So he said, doesn't matter, let China do hardware, we'll do software. That was the attitude. Now that attitude has completely changed because I believe that hardware and software are two sides of the same coin. If you don't do both, I think you're not doing justice to a country like India, where we have all the skills and the capability to do it. So that is really where I come from.
And the skills and the capability can be used both in software, but people often don't realize how much skill and talent is actually required for hardware as well. Especially in areas like design.
You see, if you look at 1976, when HCL started, we designed our own computer ground up. We made the whole motherboard, we designed the software, we wrote the operating system, we wrote the compilers, we wrote the relational database. That capability exists to do a full system. But somewhere around 1999, the government then took a wrong decision to sign the WTO agreement. And by 2005, the duty on import of hardware was made zero. As a result of that, the whole electronics industry died. The bigger guys survived, we survived, but the smaller, the MSMEs, etc., had trouble. And that really was the beginning of the fall of the whole hardware story. And that's where everybody started to get into software, including HCL. And that actually was because there is no real huge investments required for design, etc. And then, of course, scaling happened and software took off. But if you look at today, there's serious headwinds to services. Reason, AI and automation. So India cannot remain just a services country. It has to move to being a product nation. And this product nation implies that we design and make our own products in India. Till now, it was make in India. Make in India alone is not good enough. I think we should have design and make in India for every product that we can think of, including semiconductors and electronic products.
Design, branding, having the products is one part of it. And that's actually, to be honest, where a lot of the value is captured. I mean, take Apple, for example, or Nvidia. They don't have fabs, but they get a lot of the value. But a lot of that comes from the branding and the other things also, which are there in it.
Yes, absolutely right. The top end of the value chain is where the value lies. Today, where we are in the country is that we're doing a lot of EMS in electronics, which is electronic manufacturing services. It's still services, it's not product. But as we start to move, for example, the government has recently taken a decision to do passive components as a scheme. That is a great decision by the Honorable Minister and everybody in that team. But I think to move upwards is where semiconductors lie. And then semiconductor design and creating products and branding is where the real value lies.
So semiconductors is the top of the chain from whatever I understand. But what's starting to happen in India is, to your point about hardware, to your point about manufacturing, at least that's starting. We're hearing these Apple moving 25% of all iPhones to India, those big factories starting to come up in various parts, electronics are being done, companies are, Dix and others are coming up and starting to do manufacturing. Before we come to semiconductors, what is happening in the electronics ecosystem right now?
See, the government took the right decision to incent large companies to move here and start manufacturing. And also to open up the EMS market, which is electronic manufacturing services market, where they put in PLI. And these kind of schemes have helped us scale. This scale is essential for us to take the next step. The next step is to get down to adding value in the product. Till now, if you look at EMS, the value addition is 5% to 10%. That does not give us anything great. It can, this kind of business can move anywhere, which is where it is the cheapest. But to make it sticky, we need to go to the next few steps. That is where we are going now.
But that is also how China or Taiwan and others made a start. They were all doing manufacturing at scale, and that was from what you were saying. They're not necessarily designing it.
Absolutely right.
But those big Chinese factories were manufacturing products. That now is happening in India.
Yes, it's happening, and happening in a pretty big way. We are the second largest producer of phones in the world. So I think that piece has happened. But the next pieces are all happening parallelly in a lot of ways.
Okay, so now let's come to the apex predator, if you like, in the world of electronics, which is semiconductors. Many people still don't understand, but what is a semiconductor? It's called chip. We all know Silicon Valley started by being because of chips. For beginners, if you could just take us through the history of semiconductors, what are they?
You see, many moons ago, electronics, when it started, there were transistors, and everybody knows about transistors. Now, as the evolution of electronics took place, they started to put all these transistors into a single, what is called a chip. Okay, this chip would then initially took care of thousands of transistors. Then it became millions of transistors. We are now talking about trillions of transistors. So what happens is that all of this gets put into a single wafer, and from there a chip is created, which is then packaged and put into a system, which then becomes a complete hardware.
So if I can just sort of take you back to the early stages, transistors are switches which go on, off.
Yeah.
Then they started making these chips and they put then many semiconductors.
Yeah.
Today, when you're talking about any product, as you said, they've got semiconductors in them, and now AI itself is based on NVIDIA GPUs, which is the mother of all the different type of semiconductors. So it's the entire modern technology, modern civilization, pretty much riding on semiconductors.
Absolutely correct. And you really can't do without semiconductors because every product has semiconductors. And as I wrote recently, Ben Sasse, who's one of the senators in America, intelligence senator, he wrote many years ago saying that the next wars will be fought with semiconductors. And that really got proven during Operation Sindoor.
Absolutely. It's all sort of electronic and
Yes.
distant. Now, to see where India has an opportunity, again, I want to take your help in disaggregating semiconductors. I think everyone knows semiconductors are really important, बहुत बड़ी चीज़ है, but what does it actually mean? Now, there are different aspects to the semiconductor value chain. You've got basic memory chips, that's one entire area. That's slightly low-end semiconductors, which is one part of it. So there are countries which are very good in doing that, like South Korea, for example, and others. Then there's the packaging of semiconductors. There's the designing of semiconductors, which is where a lot of the value seems to be companies like Qualcomm or Nvidia and the others.
Yeah, yeah.
And then there are the companies which actually make the semiconductors like TSMC and others. Just help us understand that landscape.
So you see, fundamentally, you start with when you want to design any product in electronics, what kind of components you need to design that product. What you need initially is to make a design of the system that you want to make. Once you design the system, then you start to put in each piece of the puzzle. The first piece that you put in there is the what are called passive components, which are capacitors and resistors and those kind of things. Then you need to put in semiconductors, chips. These chips have, as I said, many transistors inside them. They're basically a conglomeration of many transistors. And then on top of that, you actually make a PCB, which is then a complete board. And inside that, you plant the semiconductor and the components that you have. Besides this and beyond this sits the operating system on top, okay, or a compiler on top, or an application beyond that. So that's how a system is constructed.
You're talking about the complete electronic product,
Yes,
right? So
yes.
in an electronic product, if somebody's looking at a radio or a computer or a display
Anything.
or a TV
Yeah.
or a fighter plane for that
Yeah.
matter these days, as you
Yeah.
correctly said. So that's what you're saying. There are semiconductors and then there's the system, the compiler and all of that. In that value chain, obviously whoever's branding the product gets the value.
Absolutely
The
correct.
Sony,
Yeah,
the
yeah,
Apple,
yeah.
the
Yeah,
Samsung,
yes.
they get the value.
Absolutely right. Yeah.
Right? Okay, so that's the electronic business. Now let's come to that semiconductor chip inside that. To make that semiconductor chip,
Yeah.
the different aspects to it, somebody is doing the design for how do you create the semiconductor,
Yes.
which is the ARMs and the NVIDIAs or the Qualcomms. Somebody's actually manufacturing that semiconductor, which is probably your TSMC or some such thing if it's advanced.
Yes.
And then there are people who are packaging it and testing it. Is that roughly
Yeah,
correct?
absolutely correct. So basically, first what you do is you use what are called EDA tools, electronic design automation tools like Cadence. You use those tools to design a chip. And once you've done the design, then you need to do a tape out, as it's called. So doing the tape out, you need to go to a foundry. In a foundry like a TSMC or even Tata's, who are now putting up a foundry, there they will take a wafer, and on top of that they will etch many chips on a single wafer. And then from that wafer, then we take it to a packaging unit where they take out these chips and package them, and then the semiconductor component is ready. But it takes that kind of process: design, foundry, packaging, and then testing. And then the chip is totally ready for it to be put into a system.
And in that entire cycle, where is the value being captured? Because a lot of people say, we all hear about, NVIDIA and Samsung and companies like that and the sort of valuations that they have right now. They're a $3 trillion company. But actually, most of those chips are made in a company like TSMC, which is sitting in Taiwan, doesn't seem to be capturing that much value. And you rarely hear about the packaging people. I mean, sometimes you do, but not that much. Where's the value in this entire chain?
The highest value sits in design. That's what Nvidia does. That's what Qualcomm does. They do. They are all fabless companies.
They don't
So
have. They don't actually make the
they
chips.
don't make anything beyond designing. Once they've designed it, they give it to a foundry who makes it. But don't underestimate TSMC. TSMC today has the highest level of technology to actually make a chip. So they start at 7 nanometers. They go down below. Most of the other companies don't have that capability. And at that level, the yield on the semiconductor becomes extremely critical. And the process that they use to make that chip is very, very complex. So therefore, they also capture value. TSMC is a profitable company. They capture value. But as you start to go up the nanometer chain, the value capture keeps reducing.
So TSMC captures value because they are cutting edge.
Yes.
TSMC is also a monopoly, right? I'm doing all of this to try and see the landscape so that where should India compete is really what I think we're trying to lead up to. So TSMC captures value. A lot of the other foundries you're saying don't, but there are
Not
not that
that
many
much,
foundries.
not that much, not that much.
Okay. There are obviously other areas where there seems to be a monopoly, like ASML, which actually makes the machines
That's
that
right.
make the machines that make the chips.
That's
correct?
Absolutely correct. Yeah.
Do they capture the value or no?
Oh, they do. They have very high profits. But ASML is a single source for certain types of technology. Japan also produces certain types of technology, which is a bit lower than ASML, but they also make manufacturing machines. But something very interesting is happening as a result of the sanctions that the US has put. China started to make machines. And they have become totally vertically integrated. They now have everything that you need to make a chip, from design to manufacturing to using manufacturing machines to packaging and then selling.
Okay. Fine. I think we've got that roughly, right? So you have to design the chip. That is one set of areas to compete in. Then you actually have the fabs or the foundries where you make the chips. Then you package them and you test them and you do assembly.
But I want to also point out that earlier packaging was considered reasonably low level. It's no longer true.
Okay.
Because there's very many changes in technology that have taken place. As a result, there are very specialized packaging units that actually do higher value added than the normal value added, because there's a complete new concept of chiplets that's come around. Chiplets means existing chips that you can take and package them together to do a full chip, okay, full system. So therefore, even packaging has become more and more complex.
All right. I think we've got the landscape. So now the trillion-dollar question: which area should India compete in? Which area does India have competitive advantage in? What are the areas that we should target in this entire chain?
You see, if you look at it, we have the best capability in design. 20% of the world's design capability lies in India. And our designers make, on an average, 3,000 designs a year. That's the size of work that we do. But all of this is done for global companies. So if you look at Intel, AMD, Nvidia, MediaTek, all of them have research centers in India. They used to design a part of the chip at some stage. Today, they design a full chip in India. So the value addition in India that they do is phenomenal. But what does India get out of it? What India gets out of it is a transfer price. The value gets captured where the IP resides. And the IP resides in the US and not in India.
You know, Mr. Chaudhary, I was actually quite surprised. Last year, I was in Silicon Valley touring some of these companies. I was actually quite surprised to find out Qualcomm has, I think, 35% of its workforce in India.
Yes.
Nvidia, when Jensen Huang came here,
Yeah.
Nvidia has, I think, what, 15 to 20% of its workforce in India.
Yes, yes, yes.
The amount of design that is actually being done out here is a lot. If you were to actually think it through, would you say India would probably be in the top 5 when it comes to actually design? Or in terms of people working on design?
I would say it would be top 2. It's as high as
Top
that.
2.
Yes, because after the US, we have the maximum number of designers sitting here. And also, there's very major thing that's happening in India. Don't forget that HCL was a hardware company. when we separated the hardware and the software, we took out the R&D from HCL, which was actually in the business of designing systems and chips. So there are companies like Wipro, HCL, Infosys, TCS also doing chip designs in India for the world. We don't do anything for India, but we do everything for the world.
So this is a very interesting insight for the simple reason that when people say, oh, India should get into semiconductors, we must make semiconductors, we only think about the foundries, right? The second
Yes,
part of
yes,
it,
yes, yes,
which
yes,
is why aren't we making chips? And I'm
yes,
glad that foundries are coming up, but
yes,
that's what we focus on.
yes.
But what you're saying is that actually the highest value item is the design.
Absolutely correct.
That's
Yeah.
where the real value is.
Yes.
And India is probably number 2 in the world when it comes to design.
Yes, true, 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 absolutely true. But we must be in every part of the semiconductor as a large country. Because I absolutely think that what is critical for India in this unipolar world is technology sovereignty. And if we don't have technology sovereignty, which means end-to-end development of a product, we're going to be really, really constrained over the years.
But in the semiconductor value chain, sometimes you have big companies that are just like NVIDIA has become NVIDIA without having its own foundry, without doing its own packaging. It's only by design. So I'm sort of like stuck on this one subject, like a bit of a dog with a bone, that if we have so much expertise in design, and that's the highest value item in the semiconductor chain, what can we do there? Does that then mean trying to get companies to figure out the IP in that, make a make in India chip, get more and more research and development done so that we can actually create design products out there? Is that the route to take?
Well, that has many, many areas to look at. What is the core of the chip? The core of the chip comes from companies like ARM. They have the real IP. Most of the chips that are made all over the world are using ARM technology. Now, a parallel route has opened up 5-7 years ago, which is called RISC-V. RISC-V has again appeared as an alternative to ARM, but that's mainly open source. That means anybody can pick up that and utilize it. But then China and other countries have started to create their own RISC-V cores. India is not behind. India, METI actually started this whole process of RISC-V promotion. And they gave funding to CDAC and they gave funding to IIT Madras to create a RISC-V core. To some extent, this RISC-V core is ready. And people have already started using this RISC-V core to design chips in India. So that IP is totally Indian. You're no longer paying any IP fees to ARM. That actually is a great direction for which METI should be really complimented for starting this whole process.
There's a center coming up on semiconductor research. Is that also working in areas like design?
Okay, that's a separate issue. But let me just stick to what I'm talking about in terms of design in India for chips. As a matter of fact, the Honorable Minister, I met him about a year and a half ago, and I suggested to him that why can't we look at what chips are required for India, for different products, and what products we need to design and make in India in terms of electronic systems. So he kindly agreed to set up a task force, which I was part of. In that task force, we looked at Indian requirements for chips. Because chip is no longer another product, it's a security issue. Look, every
Especially
Chinese
in areas
chip,
like defense and other things.
every Chinese chip can have a trapdoor. So they can get all the data back that you're using. So today, there's a huge amount of Chinese chips we are using in different products. That was the logic behind which the task force was set up. Task force has submitted its report. We have advised the government that 30 chips that we have identified should be designed in India, and over a period of time, we should cut off the chips that we import from China and replace them with Indian chips. What will that do? That will create IP in India. And we are a very large country with a very large market for different products. So therefore, there's enough volume in India for us to be successful. And what we found was that most of the chips that we need are 28 nanometers and above. We don't need the low nanometer products. Those we can do at TSMC and other places. So this strategy of designing chips in India for India and then manufacturing them here and packaging them here, we will start to create large amount of IP. Once we have got this capability going in the next 3 to 5 years, we should have a Qualcomm out of India.
That's really interesting because everyone only thinks about those GPUs that are made in, NVIDIA or the equivalent. But with so many chips being used in virtually everything, there are a
Yes.
large number of other areas to get into. So you don't have to, for the more basic chips, for the medium level chips, that's what you're saying you can design in India, have the foundries in India also, do the
See,
entire thing.
GPUs, etc., are used for graphics and AI, very high end. Normal CPUs, you don't need any of that.
All the things that you're putting into watches, into displays, into defense,
Anything.
into cars,
Yeah,
all of
yeah.
that stuff can be done here.
Automobiles, your train, for example. A train, for example, the new train that the government India has developed, it has 30,000 chips. Can you imagine that? A car has more than 500 to 1,000 chips. Everything that you have in a car, which is moving your, mirror, uses a chip.
Do you think realistically most of those, not cutting edge chips, but the other chips, can be designed in India, let's say 3 years or 5 years from now?
Absolutely correct. So ISM came up with a program which was called Design Linked Incentive Scheme. This Design Linked Incentive Scheme was to give funds to startups to make chips in India, design chips in India. The reason why it was not that successful, it's partly successful, and I will tell you why. The reason why it was not that successful because we only opened it up for startups. We should open it up for startups, SMEs, and corporates. Let's say L&T. L&T can make a chip, they have capability, right? HCL can make a chip, they have capability. So that is the change that we need to do in the new DLI scheme that the government is currently working on. Then the funds provided for designing the chip were around 30 crores per chip. 30 crores is too small an amount. So one of the recommendations that we have made to the government, and government is seriously working on coming out with a new DLI policy, will be that we should provide 100 to 200 crores per chip depending on the complexity of the chip. So you want to design, let's say, a chip for a phone tomorrow, that will be very expensive. That's not going to even be possible with 200 crores. So I think to start with, we should increase this amount, and we should also provide help to certain startups or companies who want to go to TSMC. If they design a 7 nanometer chip, they'll have to go to TSMC. So work out a model by which TSMC accepts small orders. And that is something government to government, it can be done.
Okay, fine. So part one, the design part, the highest value thing, plans are on, do a design link incentive scheme, open it up to other corporates, that part of it can be done.
And use RISC-V
And use RISC-V.
Strategic autonomy,
And the target out here is build Indian IP,
Yes.
build your own Indian companies, but
Yes.
that's when you really capture the value.
Absolutely
of the entire
right.
chain.
Yeah.
All right, now let's move to the second bucket, if you like, or the second aspect of the semiconductor value chain, which are the foundries, which are the fabs. Now, obviously, there are fabs that are now coming into India. Maybe not the cutting edge ones, but would you argue you don't need the cutting
No,
edge? It's
you
very
don't.
difficult. You can't compete with TSMC.
No, it's
in
not
that
required.
business. Is it required to have a fab at all in India or to have fabs in India?
Oh, if you don't have a fab in India, you will go back to COVID times when we were stuck with having nothing. You must have your whole value chain sitting in India. That way, we will be self-sufficient. And too many issues are coming up in this unipolar world. Tomorrow, Trump gets off on a wrong side of the bed. He can say this will not be allowed to be exported. These kind of things can happen. Europe can say this technology will not be exported. So we need to be in every part of the value chain.
We
have
may
no
not be in a
choice.
position to import Chinese
Yeah, and
chips
we
at some
should
point.
not import Chinese just because they are actually a security risk for us.
So what is happening on this part of it, on the fabs? Because there are, of course, reports in the press, a couple of fabs are coming, work has started in this entire area. India will start manufacturing, will actually start having its first fabs, and others are apparently on the anvil. If you could just take us through the landscape here.
You see, fabs are of different kinds. The major fab area is called silicon fabs. So Tatas have tied up with a Taiwanese company to make a silicon fab in India. Probably it'll take another 1 to 2 years for them to get going. It takes normally around 4 years to get a fab going.
This is PSMC, right? Which is
PSMC.
so not to be confused with TSMC.
No, not at all.
What's it?
PSMC is a much smaller company,
Okay.
but at least we've got going. The rest of the work that is going on in India at this moment is all around packaging. So a packaging unit is coming up in Gujarat from Renaissance. Renaissance is a very good company. Good company. Another packaging unit is coming up in Assam. Another very good company. They're also doing good work. So I think
That's the Tata's.
Yeah, so 5 OSATs are coming up. HCL has recently announced with Foxconn. And in addition to the silicon area, there are 2-3 other areas where we need to pay a lot of attention. The most important of them, to my mind, is the display area. Because every product that you have today, you make in India today, whether it's a phone or a tablet or a medtech device, everything has a screen. So display is something that we need to go after very quickly. That particular piece, till now, ISM did not receive very good proposals in the first and the second phase that we did. But now I believe there's a lot of interest globally to come to India. And why has that happened? That's happened because he created a very large scale manufacturing business, Apple, etc. Then we got Micron to come and make here. Micron is a very big brand. That is helping India to position itself that if Micron can come to India, anybody can come.
I mean, Apple is here, Micron is here, but just to understand the Micron project, is it on the foundry side? Is it on the assembly packaging side? If people could understand. So are there only going to be 1 or 2 fabs in India or 3 fabs in India? Or do you think there could be more?
Oh, no. We must think in terms of 10 to 15 fabs in the next 10 years. We can't just sit back and say one is good enough. We are a large country. We have a large demand and there is a global market. So therefore, we must be in large number of fabs. So silicon fabs, at least we should have 3 to 4. Display fabs, at least 1 to 2. Then compound semiconductors is a very important area. Compound semiconductors are very different from silicon. They use different chemicals to make the product. This compound semiconductor is very heavily needed for power requirements. To make any power products like say a charger for a phone or a charger for a car, all these are requiring compound semiconductor chips. So this area is something we need to pay a lot of attention to because there's a huge demand for power in India. And then comes the advanced packaging units where I talked about chiplets and stuff like that.
So if you have to look at each of these various sectors, if you're looking 5 years ahead, 10 years ahead, where do you see India realistically positioned in each of these? In where would we be in the world when it comes to design? You said we could be top 2 or top 3 in design, which is actually really heartening to hear. It's an optimistic view, and you may well be correct because we have the talent out here. How about in foundries? How about in packaging? Where would we be in the world? Based on whatever you're seeing on the ground right now.
Look, we've started too late. The earlier governments just did not bother to look at this important area for the country. And I was this lonely voice telling the government, please put in fabs. And we just floundered and created schemes that did not work. See, look at the scheme that was created at that time. The scheme was, you invest, and once you invest, we'll give you 25% after you invest. It doesn't work because there are other countries which are offering much better incentives. So Malaysia captured a huge bunch of people because they gave much better incentives than us. Today, our incentives are the best in the world. So what do we do today? If you put in 50, I will put in 50 pari passu. And you go to a state like UP, they will say, I'll give you another 25%. Pari passu. So this kind of support is available from central government and state government. And therefore, there's a lot of attraction for people to come to India because the ROI improves.
So that's what I'm saying. Okay, whatever happened, we started late. Yes, you were the person who was, but now people are listening to you, right? We're sitting in this podcast, we're saying, Ajay sir, please tell us what do we do next? And now, as you said, if you're putting up a unit in Uttar Pradesh, you're putting in 25% of the money. The Indian government or the state government are putting in 75% of the money.
Yeah,
So
yeah.
does that really help you to leapfrog? Because in technology areas, sometimes if you miss one generation or a second generation, maybe you'll say, well, okay, it's fine, I'll catch up.
I
But
don't
not
think we
really.
will be able to do that well because we have look at Malaysia. They've got 20 fabs out there. If Singapore, small little country, has 10 fabs. So we are far behind. But I think one good thing that is there in the country, I think the leadership today in the country is outstanding in this area. You have Ashwini Vaishnav, who really understands technology. You have a secretary who totally aligned. Mr. Krishnan is very, very pro semiconductors and manufacturing. Even the new ISM CEO is an excellent person. So, good news is that we have a great team leading this whole effort. But one of the things I always tell the government, which doesn't happen, is please don't keep making these changes in these people. You'll move out Krishnan and you'll move out some good people, then somebody new will come, he'll have to start from scratch. So this is something that the country doesn't do well, but doesn't matter. Good news is that the minister is personally leading this effort.
All right. Your wish list now to really become a leader in semiconductors, to catch up whatever we missed it, to extend our lead in areas where we are strong, what would be your top 5 agenda items to do?
First of all, I think we should create an outstanding DLI scheme because that is where our basic capability lies.
Design linked
Design linked incentive scheme. And there we should put up a budget of 10 to 15,000 crores. Nothing small. 2,000 crores is not going to get us anywhere. Put out a 15, 20,000 crore plan. Next 10 years, let's create 30, 40 chips out of India. Create startups that are actually in the fabless area, and one of them will become a leader. Good news is that after the last DLI scheme, I have actually personally met 3 of those startups who have got DLI from the government. And out of them, 2 are absolutely world class. And they have certain chips that they are making. And I can't name them because they're under the wraps at this moment, but they're doing superb work in creating. So the capability exists. I believe that India has the capability of creating its own GPUs. This capability exists in the country because a lot of these engineers who are actually working for the NVIDIAs of the world can come out and create startups. So if a very aggressive DLI scheme is created, very aggressive startup scheme is created, and we create the environment for them around, for example, 10, 15 education institutions where faculty is also involved. For example, IISc has a great capability to create chips because their faculty is extremely good and they actually help these startups. Some of these startups have actually come out of IISc.
But that ties in with research and development, which we always say we don't have the money for the best and the brightest. Despite what's happening in the rest of the world, the best and the brightest still say, oh, we'll go and we'll study abroad and maybe we'll work out there. So that, what you're saying, will have to tie up with a lot of investment in research and development.
Absolutely correct. Our biggest challenge in this country is we don't do R&D. Our total R&D budget is some 0.2%. So it doesn't get us anywhere. But that's rest of the areas. Here, I think we have a much better chance of succeeding and creating a Qualcomm out of India because we have all the skills.
Okay. So item number 1, a good design-linked incentive scheme. Items 2 and 3?
Items 2 and 3, focus on trying to get top partners in compound semiconductors, for example. Don't go for the second level people. It's not going to get us anywhere. You need to have a brand like Micron. So we need to get 3, 4 good brands. If we can get these 3, 4 good brands, many more will follow.
But a company like Micron has come to India.
Yeah.
So how do you attract the others? I believe TSMC is not interested in coming to
No,
India.
we don't even want TSMC today. It's very, very expensive. We don't need to have something like that. We need the $5 billion to $7 billion fabs in India. We don't need $25 billion fabs in India. That market is very, very small. But it is restricted to certain companies and it's not required. Why waste so much money?
Okay. Get good partners.
Yes.
Item number 2.
Yeah.
Number 3?
Number 3 would be to look at something very important, which is that we need to do demand aggregation in India.
Ah.
The government buying has to support the whole effort. So, for example, if you make a chip for meter, then government should say no other chips will be allowed to be imported. Only Indian chips will be put in there.
Like what's happened with defense.
Like
Defense
what's
buying.
happened in defense, and like what happens in DARPA in America. DARPA gives challenges to all startups and companies and says, if you do this, we will give you business. That's how companies are created globally. How have we created a vaccine business in this country? By demand aggregating it during COVID. We didn't get into L1, we didn't get into RFP, we didn't do all of that. We just said, okay, you guys just make it, and we'll give you the money and we'll support you also.
So you're saying the government steps up as a buyer and saying,
Yeah.
if you are able to design this chip,
Yeah.
we will buy the following numbers
Yes,
from you.
yes.
That's what you're saying.
Very critical.
Is it necessary for the government to do it? Because actually, if India is now creating this very big electronics ecosystem and electronic system, some would say that the demand will start coming automatically because if Apple is making 2/3 of its, a quarter of its products in India, iPhones in India, there will be a demand, and other companies will come. So the electronic industry, as that becomes bigger, won't you automatically get some captive demand?
I'm not talking about just the demand from the captive industry. I'm saying stop import. Moment you stop import, everybody has to buy an Indian chip. I'll give you an example. We make a huge bunch of LED bulbs in India. All right. And I went to their association and I said, supposing I get you somebody who can design the driver chip for the LED, will you aggregate all your demand and give it to an Indian company? They said, yes. We are fed up of a single supplier source from China. And China, this fellow can keep changing prices or keep changing deliveries whenever they want. So, if you are dependent on a single source from China, it's a disastrous situation to be in. And this is not just in LED bulbs, but many areas that we have similar issues. So you can demand aggregate in the private sector, but the government has to step in and say, I will not allow Chinese chips. Moment they make that statement, the demand aggregation will automatically happen. And there is a huge government demand also. Let's not forget that. Government buys a lot of phones, government buys a lot of tablets, government buys a lot of computers. All of them are today carrying Chinese chips.
Of course, what people would be concerned is that if you're dependent on government orders or that sort of demand aggregation, kal ko policy change ho jaye and the government says, okay, we think 20% margin is too much or 8% margin is too much, then what happens? That's what people
You
would
see,
be
these
concerned
are all
about.
things that the government needs to think about. How do we promote our own companies? Do we want a Qualcomm out of India or we don't? We should take that decision today. We don't want a Qualcomm out of India. Then do nothing. So I'm giving that option which you asked me to give. I'm saying be aggressive, be forward-looking, follow the way things have been done in the rest of the world.
Okay.
See, Biden took a decision 3 years ago. He wrote a
The CHIP Act.
program called Buy America. And how much money did he put behind it? $500 billion to buy only American products into government. That's what I'm talking about.
All right. Any other major suggestions on semiconductors, or these three will do a lot
I
of it?
think these three should take care of most of the issues. And as I said, the other thing that I would very strongly recommend to states, especially, see, the actual plants come up in states. They don't come up in the central government. So let's say central government takes a decision of approving a particular project. Then these guys have to go and find land and everything in a state. Sometimes states are taking 6 to 8 months to approve. Now, this is a disaster. We now need a single point control on all approvals for semiconductors because we will lose this race. Look at the way China happens. A mayor takes a decision, 3 months you can get started.
I thought the competition between states now means that you can move much faster because UP will compete with Gujarat, will compete with Assam, will compete with, with Tamil Nadu, and they will try and lure these people in. Is that not happening?
Ease of doing business is still far away.
Yeah, sadly.
You can go to any state. You cannot go to one room and get all the decisions. You will have to run around going from A to B to C to D. I remember one day I was in Gujarat. I was IT advisor to Gujarat when Modi ji was the chief minister. And can you imagine, I was trying to bring a semiconductor plant into Gujarat 25 years ago. So I took this investor, and the people there were very, very quick. They did everything, and then they put me in front of the chief minister. So when I was chatting with him, I said, Modi ji, what we need is a single point contact for all these investors to get their decisions. And we know what was his answer? He says, हमारे यहाँ single point नहीं होता है, हमारे यहाँ single room होता है. आपको कोई भी इन्वेस्टमेंट करानी है, एक कमरे में मैं सब लोगों को बिठा दूंगा. And they will jointly take that decision and approve it. What did they do in Sanand when they brought Tatas? One day decision. So that this pace of work is something I see as a country we lack. The pace is very important for us to go forward. If you're going to take 8 months to give approvals in the state or 4 months to give approvals in a state, we think we have done a great job. No, sorry. The investor abroad is thinking, if I go to Vietnam, I get a decision in 30 days. We have to compete with Vietnam. We need to compete with Malaysia. We need to say how long does it take for them to get approvals.
Some of the problems are, do you think, starting to get sorted out? Once upon a time, people said you can't possibly have any semiconductors in India because electricity is uncertain, logistics is a problem, roads don't exist. Those issues are largely getting sorted out. Logistics costs may well drop to single digits.
At the moment, I think it's still a dream. I mean, today,
well, the same podcast, Gadkari ji gave us a promise that single-digit logistics cost.
वो कब होगा देखना है. See, that has to be happen. There's another part of semiconductors which is still a lot of work has to be done, the gases and the chemicals in that area. Lot of work has been already done by ISM. And a lot of these things are being created in areas in Gujarat, for example. A lot of these things are happening. We can't import gases. You have to make them in India.
Okay. Well, semiconductor mission, you've told us exactly what needs to be done, and let's hope somebody is listening, and let's hope all those decisions are taken because it is a strategic imperative for India. But before I allow you to go, you're also, of course, the chairman of the quantum mission. What's happening in quantum? Because we are told that's the next major, that could be an area where India is first off the bat because, not too much is happening in quantum in actual terms. How do we avoid missing the quantum bus in quantum computing?
Well, we've started pretty much on time, I would say, maybe 5 years late, but we are catching up. What we have done in the quantum mission is that the government has put out 4,000 crores for this mission, and another 2,000 crores is sitting with Department of Space, Atomic Energy, and DRDO. So close to 6,000 crores. METI has put in 500 crores, and they have promised to put in another 500 crores because Mr. Krishnan said, I don't know why we missed out the quantum bus in METI. METI was not part of the scheme. But now, Mr. Krishnan has said, absolutely, we must be part of METI. METI must be part of it. So that's great. Now, what's happening is that we have set up 4 different hubs for creating the different technologies. So the first area is quantum computing, second is quantum communication, third is quantum sensing, and fourth is quantum materials. So
what's the difference between them for people who are lay people like me?
Quantum computing is basically...
not that any of us understand quantum to start with.
No, quantum is not that difficult to understand. Let me just put it in very simple words. In normal computing, which is called classical computing, you work with 0 and 1. In the case of quantum computing, you have 0 and 1. What that means, it's parallelism. What that means is much faster. But it's much faster for specific applications. You don't do accounting on quantum computers. You do chip design on quantum computers. You can do drug discovery on quantum computers. You can do climate work on quantum computers. So high-end work is where it will reduce the time to do the calculations that are required to be done. So that's quantum computing. And that uses different materials to make a quantum computer. In this mission, and this is a mission, so in this mission, we are treating it like a product mission. So we have targets for each and every area. So in quantum computers, we must make 1,000 qubit computer. Qubit is equal to the bits that were there, 0 and 1. Qubit is 0 and 1. Okay, so 1,000 qubit computer we have to make. in the area of quantum communication, where you need to have secure communication. See, if a quantum computer comes up in China and it attacks our financial systems and our grid systems, then we will fall down as a country. So we need to be quantum secure. And what this technology does is that it will make you secure from any spoofing or entry into your cybersecurity. So the current cybersecurity has to be replaced by quantum cybersecurity. So that is where we are working, where we have to now demonstrate and show 2,500 kilometers of fiber and 2,500 kilometers of space secure quantum communication. The third area is quantum sensing. Sensing is going to be a very big deal for the world, because that is where the quality of sensing that we can do through quantum technology is much, much bigger. Okay? So you want to see what is under the ground, you can do it extremely well. Tomorrow, Navy wants to use it for warfare in the submarines. Instead of GPS, you can replace it by quantum sensing, which is totally secure. So that is where sensing is coming in. And then, of course, IIT Delhi is working on creating newer materials for making quantum computers and quantum devices. So these are the 4 areas that we are working on. I think we made very good progress, but being coming from a private sector, I'm always a little critical because I want to move much faster.
And which of the 4 do you think India is most advanced in, and where do we still need to do a lot of work?
Quantum communication. Quantum communication, a lot of work was done 15 odd years ago by a professor in IIT Madras, Professor Anil Prabhakar. And he was the guy who created the whole theory of creating these products. And then he created a startup which came out of IIT Madras. And that is a guy called QNU. That is a topmost startup in the country. The good news is that we have close to 100 startups in quantum today. And we have a very, very liberal scheme for quantum startups. So instead of giving those 1 or 2 crores that typically government used to give to startups, we give up to 30 crores per startup. And in special cases, 50 crores per startup. Wow. And that is a complete game changer. And when the finance guys asked me, how can we give away 30 crores like this, we came up with a beautiful scheme. And we said, when this company goes for VC funding next round, whatever is the valuation at that time, government will get 30% discount on that valuation. Government has the right to buy that stock. Just imagine. So a completely new way of thinking is happening in the government, and government has approved it.
That's fantastic. So you think we will not miss the quantum bus?
Hopefully. Let's see.
All right. Ajay Chaudhary, always a pleasure talking to you, and all the best both with the semiconductor mission and with the quantum mission. Let's hope they both work out.
Thank you
so much.
Good talking to you. Hi, I'm Ajay Chaudhary, and you're watching me on the India Story podcast with Vikram Chandra. You can watch this podcast on Hook or any other place that you like to watch your podcasts.